Thanks for the introduction. Today I'll be talking about what fuzzy matching is and how to use the tool in Alteryx. There are many different ways to customize this tool in Alteryx, so I'll only go through the most important ones that would be relevant for a beginner. By the end of the training video, I will go through an example with a dataset and show you how this can be applied in a workflow. Hopefully, this will be into the complex world of fuzzy matching. In essence, fuzzy matching is a process to identify duplicate data that isn't exactly identical. It is important to note that even though there are complicated algorithms running behind the scenes to get a score, it is still very much an art to determine what is a duplicate. Here's an example of what I mean. In this workflow, I have two inputs, one with two records from a company's customer database with the name, address, and amount of purchases they've made so far. And in the second dataset, we have new data gathered. If we look at both datasets, we can see that Adam exists in both, while Bob exists in the original database, and Noel and Robert are new customers. If we look at both Jane and June, we can realize that they have the same address, but because one is named Jane and the other is named June, they won't join. In this case, we can make a safe assumption that they are the same customer, but maybe for some reason it was typed incorrectly. So if we look at our join results, when we join on both name and address, we can see that only Adam Clark joins, which is correct. Noel and Robert don't join. Bob doesn't join, but Jane and June also don't join when we want them to join. So this is where fuzzy matching would help out to identify June and Jane as matching pairs. So now that we know what fuzzy matching is, let's have a look at the tool itself. We have a bunch of different configurations and settings here, so we'll go through the most important ones. So the first one is purge. In purge, we compare all records from a single source to identify duplicates. So if we look at our previous data set from the last example, if this was just all from one data source, union together, and we ran this through a fuzzy matching process, we would expect Adam and Jane and June to match. So this is just basically deduplicating one single source. In purge, the first case where we had data from the database and new data over here is an example of what a merge is. We're comparing different data sources to identify duplicates. We need a source ID field to be able to distinguish the different data sets. And generally, we should try to purge each data source first before merging to speed up the process, as merge is quite a computationally expensive activity. That's why removing or identifying duplicates in each data source first is a good idea. Up next is the record ID. So this is the unique record ID. In purge mode, it should be quite self-explanatory. Each record has to be unique. But in merge, when we have two different data sources, we actually want to give a unique record ID amongst all the data sources. Then we have the match threshold over here. So we can see here that it's set to 80%. So this is the minimum score required for two records to be qualified as a match. So once it generates a score, in this case, if the score of the two records is 80%, then it is qualified as a match. Then we have the match fields. So this is the minimum score required for two records to be qualified as a match. And just to distinguish that, the match threshold is the overall score. So it's basically the average of all the match fields. So each individual field will have its own minimum threshold that it must meet. We'll go through an example here of how the thresholds work. So let's say we have these thresholds. So we have the overall match score threshold of 80%, and each field we have address as 90% and name as 50%. So in example 1, if we have an address score of 90%, name score of 70%, and match of 80%, we can see that we've fulfilled every single threshold, including the overall match score. Therefore, these two records that generated these scores would be a valid pair. So the match score, just to reiterate, is the average of the match fields. So the average of 90 and 70 is 80. In example 2, we have an address score of 85%, name score of 95%, and match score of 90%. So despite the actual match threshold being met, so we can see that 90% is higher than the 80%, the address score is actually lower than the 90% for that individual field. Therefore, it fails. And similarly, for example 3, we can see that both of our match fields have hit its criteria, so we get 100% and 54%, but the average of these gives 72%, which is lower than the 80% threshold required for a valid pair. So that's just a bit of how the match thresholds work. And Alteryx has been nice to us in that we already get some pre-configured options ready to go for the match fields. So as we can see here, there's about 10 or so configurations ready to go. I just grabbed this basically straight from the Alteryx website, but included the most relevant points for each field. You'll notice down below in the configuration pane for the fuzzy matching tool that I didn't mention the advanced options in the slide. I will go through some of these options in a sample workflow as they do come in handy when trying to assess the accuracy of our results, especially the first option here, the output match score. It allows us to see the score for each match pair and help figure out whether it was a valid duplicate or not. Now we'll spend the rest of the training going through an example workflow that showcases the fuzzy matching tool. In this workflow, we have two data inputs, a list of 533 restaurants from Fodor's and 331 from Zagat. Both these data sets contain the restaurant name, address, city, food type, and phone number. For this exercise, we will ignore the phone number as it makes the fuzzy matching very easy, and we'll also ignore the food type. We'll focus on name, address, and city. I can tell you ahead of time that there are 112 duplicates. Our goal is to see how close we can get to that. Let's first start by doing a simple join. So let me just run the workflow to give you a better idea of what the data looks like. So as you can see here, we've got all the fields, and I'll do a join. But before I do that, it is always good practice when trying to join fields to make them the same casing and to, in this case, get rid of any punctuation. So I will use the data cleansing tool for that. And I'll basically get rid of any leading or trailing white spaces, any tabs, line breaks, and duplicate white spaces, punctuations, and then make everything uppercase. I'll do the same here. And if we run this, we can see that it's changed the data to look like this. And now I will do my join. And we'll see how we go. So let's join on name, address, city. And we get 26 records. So remember, there were 112, and just by doing a simple join, we could get 26 of those, which is, I guess, okay for just a join. But now we'll do the fuzzy matching process, and hopefully we can get a lot more than this. So if you remember in the fuzzy matching tool, hold on, so I'll just get rid of all of this, and I'll pull up the fuzzy match tool. We will be doing a merge because we have two different data sources that we're comparing. And so remember, in a merge, we need a source ID field, and regardless of which mode we pick, we need a record ID field. In this case, we've been given an ID field. This one starts at 534, and this one starts at 1. And if we scroll all the way to the bottom, it only goes to 331, so we know that these IDs will never overlap. So that's our record ID sorted out. And now we just have to give it a source. So what I'll do is create a new field called source. And I'll name this one photos. And just in case there wasn't an ID field, you can create it yourself. And to make sure it's unique, what you can do is give it a record ID field. And we'll create a new field here called record and concatenate the source with the record ID. And since the record ID is an integer, I'll convert it to a string. And now that I've concatenated the two, I'll copy the same thing here. Run this. Oh, let me change the source here to Zagat. And now we have the source and a unique record. And even though the record ID still starts at 1, the fact that we have the source included will make it unique. But since we have already been provided with the ID, we don't really need it. So I'll just get rid of those. And just remove this record field. So what I can do now is simply union the two datasets together. And do what I did with the join. I'll also cleanse the data. So get rid of any punctuation and modify the case to uppercase. And this is what it looks like before we put it into the fuzzy match. So we have all the rows with our sources and unique record IDs. And before we throw it in, actually, since we aren't going to be using the type and phone number, I will just get rid of it now. Actually, I might do it beforehand in the beginning here, so that when I check the data later on, these fields won't be there. Okay. So now we can put it into the fuzzy matching. All right, so we're going to be using our source ID field as source and record ID, ID as the record ID field. Cool. So for our first run, I think we'll just use the pre-configured options, leaving all the thresholds as they are. So for name, I will just leave it as name. Address, I will leave as address, and city. In this case, I'll leave city as a name. Okay, and what I'll do is output the match score so that we can see the scores. One thing to note with the fuzzy match tool, so I'll run it, is they don't actually give you the fields afterwards. All you get is the ID fields. So I don't actually know what name or restaurant this is. What if I want to know, I'm going to have to join it back with the dataset. And we are also now given the score. So we're given the overall threshold score, like the match score, and each of the scores for name, address, and city. So what I'll do now is, before I join them up, you can notice that for this ID 322, it joins to ID 637 from the other dataset. But notice how it repeats twice. Generally, this is what happens when a key is generated here, but could have multiple keys that are still valid. So it'll generate more than one key in certain cases. And what we need to do is simply just add a unique field, add a unique tool for ID and ID2, and that'll reduce the list down to 67. So that's 67 matches that we found so far. And if we remember, we only had 26 from the join. So this is already a pretty good improvement. But what we'll do is join with the rest of our data over here. So to figure out what field to join on, we can see that ID2 has the 500s in there. And if we remember, that was the photos IDs side with the 500s. So what we'll do is join ID with ID. So we'll just get rid of ID. And if we run this, oops, sorry, ID2 matched up with it, my mistake. We can get all the information for ID2. But I also want to compare with the other data set to see if these are actual duplicates that we found. So what we'll do now, actually I'll just zoom out a little bit, is join the second data set. So now we join ID on ID, get rid of ID. And I think what I'll do is, to make it more obvious which one's which, I'll add a prefix. So we can use add prefix to field names. This one is photo. And in this one, I'll get rid of right. So let's clear, oh, my mistake. Let's go back. Let's clear, highlight renames, add prefix. So we're going to add the get. And I accidentally got rid of these ones, so I'll add them back in. Photos. And what I'll do is I'll put them side by side. So you can right click and drag. Okay. So we can move this a bit narrower and compare our findings. So let's put a sort here and sort by match score in descending. So we'd expect about, the first, right, 26, 27 being perfect matches. Down here. And that's because the join from before gave around that number. They're essentially the same. So if you look here, Hotel Bel Air, Bel Air Hotel, and the address is the same, and the city is the same. So these all look pretty good. Let's scroll all the way down to the bottom. And we can see our match score name was 85, which is good. Yep, these look exactly, I mean, they should be the same, even though this one has New York City in it. The address score is 100, and the city is 88. So this one says New York and New York City. So that's why the join from the beginning didn't work, because they're different. But the fuzzy matching has picked up that these two being a pair. Cool. So now what we want to do is try to see if we can improve on this score. So what we can do actually before we try to make any improvements is look at the duplicates that we know exist. So I have them here. So these are the actual duplicates in the dataset, all 112, and we'll join with what we have and see what we're missing. Cool. So these are the ones that didn't match. We can have a look at them. So this record over here, the city looks exactly the same, the address looks the same, but the name didn't quite match. So we got these extra characters here, and due to the fuzzy matching process, it didn't hit its minimum threshold and must have failed this pair. Seems like a similar case here where we have Phoenix and Phoenix at the Argyle. They are the only difference because the address seems to be pretty similar. Oh no, it seems like both the name, address, and city seem to be slightly different. So what we can do is potentially lower our threshold to capture some of these pairs. So what I'll do now is maybe tweak some of these. I think what I'll do is I'll leave the match threshold as 80, but maybe tinker with the individual match fields. So I don't think I'll change any of the matching functions, but I will lower the threshold. So I think the name, as we saw before, it could be missing a few of the words from the restaurant name. So I'll lower it quite a bit down to maybe 70. And for address, I'll do something similar. Maybe I'll just reduce it down to 75. Again, there's no real science to this. You just have to look at your data and try to guess what would be a good fit. And now that I've run this, we've gone all the way up from, I think it was 67, all the way up to 90, which is way higher than before. So you can see here that it went from 90, but when we look in the inner join, there's 88. And what that means is we've matched two that shouldn't technically be matches. Not too sure why, they look like matches to me, but um, if in reality you did have a bunch of matches that shouldn't have existed, it means you have some false positives and you may want to tinker with the match thresholds, or you could just filter them out manually. So let's see which ones didn't match. If we have a look here, it seems like these fields didn't join. It seems like Carmine's is an exact match for the name. I think the city would have passed, but because of the address, if we have a look here, for photos, it seems like they show a bit more information with the address. It says between 90th and 91st Street. So what you could do is maybe clean up the data. I could quickly show you how you could potentially do that. We could do a bit of regex where if we can just remove everything that includes between and after. So if we see between, we'll just replace that all with nothing. And if we do that, we get a few more matches. We get 90 matches now. And the only ones that remain for between, I guess this is something else that could become a problem. This one says 7th with a 7th, and this one's 7th, and it spells out the entire word. So in these cases, you just have to figure out whether you still want to keep tweaking or just manually mark these as duplicates. So I think I'm pretty happy with these. We've basically got what, 90 out of 112 of the matches just with some basic fuzzy matching. I'm sure if we played around with it more with some of the matching styles, we could get a lot higher. But I think this is good. Thanks for watching this training video on fuzzy match. Now we'll go on to any questions and answers that you guys might have.